Hi, everyone. In this video, we are going to cover section 14.5, linear correlation, and this is the final section of the course. Awesome. We are going to use Excel to do our calculations, and you'll see why when we get to them. So plan on using Excel as you go through your homework. The plan for this section, we're going to construct scatter plots in Excel primarily to show the relationship between two variables, explain the properties of what is called the linear correlation coefficient, and then use linear regression to find the line of best fit for a set of data points. All right, first thing, scatter plots. Scatter plots, when you plot an X and a Y and there's points all over the place, that's a scatter plot. Pause the video, feel free to read through the formal definition for a scatter plot. And our example here, we have an instructor wants to know if there's a relationship between the number of tutoring sessions and the exam grade. You can see the table at the bottom that lists the tutoring, lists the two variables, and they collected data from 10 students, and we are going to make a scatter plot. A little bit later in the video, I'll show you how to do that in Excel. For now, I'm just going to click and show you what the scatter plot looks like on the next slide. If we plot the X's against the Y's for each of the 10 students, we get this scatter plot. Notice the X-axis has our number of tutoring sessions. The Y-axis displays their grade. And what you can kind of see is a positive trend there. As the number of tutoring sessions increases, the grade generally increases as well. That's the first thing that we do is we make a scatter plot and then interpret what the relationship is between the variables. Okay. The next big thing in the section that we will definitely use Excel to compute, and you'll see why, is called linear correlation. So a correlation or a relationship between two variables. The linear correlation, if the points that we just graphed that you saw on the last slide, if they tend to lie in a straight line, that means there is a relationship between the variables. And the number that we'll compute tells us to what degree the points are in a straight line. If they're in a perfectly straight line or if they're in a mostly straight line with some variation, that's what the linear correlation tells us basically. And there is the formula. Look at that beast. That is a terrible formula. You will never use that formula. Like I said, we're going to use Excel, but that is what the formula looks like. It's a lot to compute by hand, so we won't do that. We're going to use Excel. So actually, let's do that. So I'm going to switch over to Excel here, see if I can do this correctly. There we go. All right. So we have the number of tutoring sessions and the exam grade for the 10 students. First thing, if I want to make a scatter plot of those two variables, I'm just going to click and drag. So I'm holding my mouse button down. Let me do that again. I'm going to click on this first one, drag across and down. The whole time I'm holding my mouse button down and then let go. And then I am clicking on Insert. Here, this guy right there, there's my scatter plot and this first one. All right, so there's my scatter plot for those two variables. You can see Excel doesn't do a good job of labeling the axes. We can add that in if we want to, but you can see that there's that same positive trend between the two variables. Okay, but to actually compute or to tell Excel to compute the correlation coefficient, here I am down in this cell right there, and I'm going to hit equals and then start typing the word correlation, C-O-R-R-E-L. And notice it shows up with the little C-O-R-R-E-L, and it says returns the correlation coefficient between the two data sets. That's how we do it. You don't type the whole word, just the C-O-R-R-E-L is like the code for Excel to understand what you want. All right, and then I'm going to hit a parentheses, and then notice it says array 1, comma, array 2, and then I have to close the parentheses. Now you can either type in the locations, or I personally prefer to click and drag. So array 1 means my X's, so I'm going to click and drag to highlight that column, and then I have to type a comma, so type the comma, and then click and drag for the second column. Oops, I went too far. Try that again. Click and drag the second column. Okay, so I'm not highlighting both columns together. It's the X column, comma, the Y column. All right, and then I close the parentheses and enter, and we get a big ugly decimal, which is fine. The first two digits typically we use for a correlation, or sometimes three, but a correlation of 0.89, 0.89 is my correlation for these two variables here. All right, so what does that mean? Now let me go back to my presentation. What does that mean, right? If we get a number, we will always get an R value between -1 and +1, and it can be those numbers. If you ever get +1 or -1, I'm blocking part of the wording here. There we go. That means that the points are on a perfectly straight line. All right. If it's positive, there's a positive correlation between the two variables. Negative, then it's a negative correlation, meaning the points would be pointing downward. The closer you are to 1, the stronger the relationship between the two different variables. Okay. The closer you are to -1, the stronger the negative relationship. As one variable goes up, the other goes down. The closer you are to 0, no relationship. Okay, so if you get a correlation of like 0.25, that's a really, really weak linear relationship. If you get a correlation of 0.89, that's pretty strong. That's a pretty strong relationship between the variables. All right, so those are our properties. Here's a couple of examples of scatter plots and what the correlation could be. Here, this one is close to +1. This one, see the points are scattered. They're all over the place. There's no relationship there. It's close to 0. And then the third one, the R is negative. See, as one variable goes up, as the X's increase, the Y's decrease. Okay, so that's positive and negative correlations. All right, one more example. This one will compare the weights of different cars, and this is the weight in hundreds of pounds. So that weight of 29 means 2,900 or 2,900 pounds, and then what the mileage is on that vehicle, how many miles per gallon it gets. All right, so if I go over to Excel, I'm going to click on my other tab that I created, and let me zoom in on it so you can see a little bit better. There we go. All right, so the correlation here equals CORREL, parentheses. Click and highlight, boom, comma, click and highlight. So when you do your homework, you're going to just type those, the X's and Y's that you're given in the various problems into Excel so that you can then compute the correlation. All right, so I'm not sure how well copying and pasting will work, but you can definitely type in the values, but go down a column, not across a row. It's better that way. All right, here we go. Correlation, -0.85, -0.85. So what that means is if I make the scatter plot, I already know ahead of time that the points will be pointing downward. And let's see if that is in fact the case. Insert my scatter plot. And hey, look at that. As one variable increases, the other one decreases. That's we kind of see that ahead of time with the correlation, and that is also modeled in the graph. 0.85, pretty strong, so it's a strong negative relationship between those two variables. As the weight of the car increases, the number of miles per gallon, the mileage of the vehicle decreases. All right, back to my slides. Let's see. The last topic of the section is called a line of best fit. All right, that is also something that we'll find in Excel. It's the line that models your data best, right? So the line of best fit, the formal way of kind of talking about it is it minimizes the sum of the squares of the vertical distances. Very formal way, but it makes the distance between the line and the points as small as possible. Okay, that's what the line of best fit does. Makes that distance as small as possible. Called the line of best fit. That's it. And we'll find it in Excel. That's the formula. Don't worry about the formula. It's a beast. There is a formula. It has meaning. It has value. But for the purposes of our course, let's just stick with Excel. All right. Here we go. So the tutoring example, again, we're going to go back to that and find the line of best fit. Here I am in Excel. Click on my tutoring tab. There we go. All right. So the way that you find the line of best fit in Excel, let's see. So I did this a few times before, my video to practice. Let me move this down. All right. So what I'm going to do is I'm going to click on this plus sign here because I want to add something to my chart. I'm going to go down to the last guy. It's called the trend line, the line of best fit, also known as the trend line. I'm going to click on that, and hey, there it is, dotted line there. If I click on more options, there it is. I can display the equation on the chart. So let me do that again in case I lost you. So I'm clicking on the plus sign. I'm going down to trend line, clicking on that checkbox, and it adds it onto the graph and as a dotted line. And then the arrow, more options. I'm clicking on more options, and it's not giving me the same options as last time because I want to add that equation to the chart. Let me try that again. Trend line, more options. Yeah, there it is. Display equation on chart. Display equation on chart. All right. And there it is. Move it up so we can see it a little bit better. Oh, come on. Okay, it doesn't want to move. But let me type it over here. Y equals 0.9729 x plus 28.37. Let's go. Okay, so that is my equation, y equals mx plus b, slope, y-intercept, right? That's the equation of the line of best fit. It best models the 10 students in that professor's class. Okay, back to my slide here. Interpreting what those two things mean, so y equals mx plus b, the slope, the m is the 0.29, the b, the y-intercept, was that 28.5, I think it was. Okay, and so what those two numbers often have meaning and value in like the real context of the problem. So, excuse me. So for the y-intercept, the 28.5, this number right here, if a student had 0 tutoring sessions, that's what they would expect their score to be, right, based on the 10 students in the model. All right, and then the slope 0.93, or as a fraction 0.93 over 1, for every one additional increase, well, how am I going to say this? We expect the exam score to increase by 1 point for each additional tutoring session, okay? Because 0.93 is kind of close to 1, so we're like interpreting that as rounding to the nearest whole. Every 0.93 increase in Y, tutoring sessions, your test grade goes up by 1 point. So that's kind of a slope of 1 if we think of it as in a rounded way, all right? So that's the interpretation of what that means in context. All right, so that is what you'll be doing. You should definitely use Excel. You can also probably use Sheets. The commands should be pretty similar, but let me know if you run into any problems, and I will be happy to help. That's it. That's the end of the video. Thank you very much for listening, and have a wonderful day.